Hi there, Turgeon here, bringing you physics from afar. Graphing data. This might seem like math from afar. This modeling part is where it really turns into physics, but I don't want you to worry about that too much. We're going to focus on how to use Google Sheets. Take a look at this data set. You don't have to know what this means. You don't have to know what any of these mean. I'm going to follow these instructions using this data set. I want to generate a graph. Now, a lot of emphasis has been placed maybe up to this point in your education and like making a graph by hand. I'm not sure about that. I do think there's value in that, and I will have you do that as well. Right now, I just want you to know how to use Google Sheets to make a graph. It's finicky. They update it. I might show you something that in a week changes. That's for real. I've seen this happen. To start with, I'm going to highlight the data, including the titles. You have to know that this is going to go on the x-axis and this is going to go on the y-axis. So your first column, when you set it up, is going to obey that rule, and most graphing utilities, most programs will do that. I just put the x and the y as labels, don't highlight those. So highlighting, and I'm going to insert chart. And I don't have this memorized. I just kind of figure this out every time. And it's a good thing because Google keeps changing, and you know, it would be kind of a waste to memorize it. Now, this happened to have chosen scatter chart. Often they choose other things. They seem to like line charts, but you want to choose scatter. If they don't give you that, you can go down here and you can choose scatter. And I'm immediately going to go into customize because the directions say that if it's linear, then I'm going to add a trend line. But I'm not just going to stop at trend line. That thing looks strongly linear. I want to have a label, and the label I want to be the equation. And you can show the r-squared value as well. The r-squared value is not the percent error. It's kind of like a probability. It's like there's a 99.9% chance that this truly is a linear function that describes this data very, very, very well. Now, what we do want to take note of is the slope is 0.3. Slope will be a very important thing. This y-intercept sometimes is important, but I want you to notice that it's virtually 0 because -3 means 10 to the -3rd. That might seem familiar from your calculator and stuff. The capital E with the -3 means 10 to the -3rd, which means virtually 0. Which reminds me that I don't think this is necessarily starting at 0. So you usually want your graph, no matter what, to start from 0. So I'm going to go to horizontal axis, and it's usually automatic, but let's see if that changed a little bit when I add a 0 there. There it goes. Now it looks like it's really forcing it to go through 0. Whoa, didn't mean to reverse axis order. So now this looks cleaner. So as a habit, we should do that. We should make sure that it's not taking too many liberties. Let's see what it does here. That appears as though it already was. Now, labels. Oh, by the way, again, it's finicky. If during the setup process it doesn't seem to have wanted to do that and graph it properly, it's doing something weird, you might have to play around with these check marks, which it doesn't appear to have a universal decision. It doesn't appear to have a default that it always does it a certain way. So you might have to play around with those check marks there. I can double click here. Let's say I wanted to add units. The units of friction or newtons. Okay, you could double click this and it'll let you change the title over here. Maybe, oh, you can change the title right there as well. Now I have this thing that is basically, I think I can, yeah, you can copy this like an image and place it into your Google Doc, and then you could have a bunch of these in one Google Doc. Now the observation part, you know, I want you to look for patterns. I'm interested in what you say. I'm interested in what you see. Just go off. I mean, it's really hard to not get 100 on this. if you can follow those instructions for all these data sets, you're not always going to get a line. Remember that. And that's one of the things I'm asking you about. And just take these prompts and go off. I want to see your thinking process more than anything else. This is not about quick answers. In fact, there isn't an answer. There isn't a correct answer. Okay. So please take the intellectual leap, take the mental risk, and just go ahead and tell me what patterns you see and respond to those prompts. This has been Physics from Afar.